Now to find vertical asymptotes, you're really just looking for parts of the graph that can't equal 0. So you're looking for denominators because anything over 0 is undefined, can't do it. So easiest way to do this is write yourself a little equation showing the part of the function that can't equal 0 and write that part is not equal to 0 and then solve it. It's really tempting just to look at it and jump to an answer. And with easy ones, you could probably do that, but I would recommend doing this every time because it'll just prevent you from making mistakes on the more complicated ones. Now, the values of x that you find can't exist, those will be the vertical asymptotes. Factorising might help. Okay, so we'll have a look at some examples where you might need to factorise here. Now, we've got 3 examples here. Now, you might be tempted to just say, oh, look at that, the x can't be 3 because then 3 take away 3, that would be 0 and we can't have it. But don't forget that we're trying to prove this not only to ourselves but to examiners. We're showing our thinking. So one method that works well all the time, spot the bit that can't equal 0 and write down what it is. It's this part. So I would literally write 3 minus x can't equal 0. Now it's super simple to solve that. Let me just use a better pen. And I can see now that x can't be equal to 3. So as soon as I go to graph that function, straight away I'll be thinking, right, when x is 3, the graph's not going to go there, so I'm going to have an asymptote. Next one, 4 minus x squared is the part that can't equal 0. So I write it like that. Now, 2 ways to solve this. I could just add x squared to both sides and say 4 can't equal x squared, or x squared can't be 4. Just be careful here because you need to remember that when you take the square root of both sides, x can't be plus or minus 2. There's 2 things it can't be. Now, could factorising help us? It could. I can factorise this. It's the difference of 2 squares. So if I did that, then in this step here, instead of writing these bits, alternate working would be to say 2 minus x and 2 plus x can't equal 0. Now, we know how to solve this when it does equal 0. We'd say x must be 2 or minus 2. So here we're just saying x can't be 2 or minus 2. And that can be a nice, easy way just to show your working and make sure you've got the 2 answers, because someone doing it this way might get full marks, but if they accidentally fail to think of that negative 2 and just put x can't be 2, they'll have missed something. So then when you go to graph it, find where your 2 is and your negative 2 and put your vertical asymptotes in straight away. Alright, this one here is a good example of one that looks like it might need factorising. Now, you can factorise it straight up and factorise that whole thing by just factorising the bottom. Instead, I'm going to jump straight to my first line, so there's less writing to do. I can see that this is the part that can't be 0. So I write x squared minus x minus 6 can't be 0. And now I can easily factorise this part. I can see that it's a quadratic. So I set up my shape of what I want. I'm going to need x's here and here. Now I need 2 factors of minus 6 that add to make negative 1. So I need plus 2 and minus 3. So just as I could solve it if it was equal to 0, I'd say that x needs to be negative 2 or 3. I can easily say x can't be negative 2 or 3.